structural strengths and cavitation occurrence characteristics 관계였고 그 성함이 쓰진 않지만 with as rapid creep, right?
And the shuffle hop.
Sorry. 발표를 마치도록 하겠습니다.
Good morning, everyone. This is MD Ashraful Haq, master's student from Jumna National University. Today I am representing flow-induced noise and cavitation control laboratory under the Department of Autonomous Vehicle System Engineering, and my topic is to present a study on correlation between water shear strength and cavitation occurrence characteristics. So let's begin from the beginnings. So here are my discussion contents. First, I'll say what motivates us for this research, and obviously the pioneer research work, and then I'll show the experimental apparatus of ours, and finally I'll discuss the key outcomes of what we find. So, from engineering perspectives, cavitation means noise generation, material erosion, performance degradation, and so on. So, from the high-speed visualization, we can see that even if the flow condition remain fixed, I mean this is for 15-degree angle of attack, and the cavitation number and also the flow velocity remain fixed, we can see a significant difference between the two dissolved gas content, between 4 and 10 dissolved gas content. So, our main objective for this study is to clarify the distinct sensitivity of vortex-dominated cavitating flows to water conditioning effects, and to support a more reliable interpretation of cavitation thresholds to marine hydrodynamic model testing. So here the first one is represented from the 21st Symposium on Naval Hydrodynamics. There they have showed the relationship between the dissolved gas content and the water tension with respect to the cavitation inception number. So there they presented that the higher nuclei content promotes the earlier cavitation inception, and also the thickest water, that means the highest tension, it delays the cavitation inception significantly. And they finally represent that the thick vortex cavitation and dead surface cavitation and bubble cavitation, and with its effect of dissolved gas content. And there they have found that the thick vortex cavitation is highly affected by the dissolved gas content. And the lower one is from International Journal of Multiphase Flow. There they have showed the scale difference, and from the left figure we can see that even if we predicted TVC without nuclear effect and with nuclear effect, there is significant difference. So this is our Chungnam National University cavitation tunnel, and here are the brief discussions. And the right one shows the water tank and the degas tank. So how we control the dissolved gas content in our cavitation tunnel? It is important to know, right? So water is circulating from the water tank to the degas tank, and we can control by using the vacuum degasification system, by using the vacuum degasification system, or at what preferred dissolved gas content we need. And the right one, and the right lowermost figure, it is taken when we conducting the experiment. This is the hydrofoil, the LED lights, and our test section length is 1.4 meter, and the area of the dimension are 0.1 meter square. So this is another schematic view of our test section. Our hydrofoil model was NACA 16020 and 8060 millimeter dimensions, and the test conditions are 9 degree, 12 degree, and 15 degree angle of attack, and our DO range was 4 to 10 measured as parts per million, and our velocity range was 6.9 to 11.6 meter per second. So we are measuring the dissolved gas content, right? So it is important to know that what sensor we are using to measuring the dissolved gas content. So instead of using the traditional polarigraphic sensor, we have used the latest MATLAB Toledo optical DO sensor because its measurement response is 6 times faster than the traditional polarigraphic sensor, and its accuracy, reliability are more enhanced than the traditional one. So the left schematic is our optical DO sensor, and the right schematic shows how it works. So if I describe shortly, the optical fiber emits the blue light and causing the sensing element to the luminescent die there, and the sensor cap contains the diffusion layer, and oxygen constantly moving through this diffusion layer and interact with this luminescent die layer, and this principle is called as the luminescence quenching mechanism. And finally, a photodetector measures the reference LED light with this luminescent die layer, and thus we get our preferred dissolved gas content. And it is actually important to know that what is the relationship to the dissolved gas content with respect to the nuclei concentration. So from here we can see that the relationship between the dissolved gas content with the nuclei concentration by mass. That means 1 parts per million corresponds to 1 times 10 to the power minus 3 kg per cubic meter. So, when cavitation is inserted into a vortex system, it is important to know. So, when the vortex core is strong enough and the air nuclei entering into a vortex system, cavity inserted. So, from here we can see that after the cavity inserted in a vortex system, and as time goes on, it convected downstream through the T vortex system. So this is for a fixed condition at 4 ppm and 9 degree angle of attack. So here this slide presents the complete cavitation process. So the first process is intermittent T vortex cavitation insertion, and as sigma goes down, we find the Atlas T vortex cavitation insertion, and as it goes down, I mean the pressure reduction, we find the Atlas T vortex cavitation, leading edge sheet cavity, and finally the cloud cavity. So it is important to know that dissolved gas have effect for the inception location or not. So I mentioned already that we have tested at diverse condition, I mean 3 angle of attack, 9 degree, 12 degree, and 15 degree. So let's look that the intermittent T vortex cavitation, is it have effect for DO or not? So we find that though the cavitation likelihood process has effect on DO and angle of attack, but if we talk about the preferred inception location, we can see from the figure that at 4, 6, 8, 10, the inception location is not fixed. So DO doesn't have any effect in terms of preferred stimulus position or location. So it means that the events are stochastic or intermittent. It doesn't have any fixed rules in terms of dissolved gas content. So that one is for 9 degree angle of attack, and this one is for 12 degree and it goes on as 15 degree. We find the same thing at 3 angle of attack. So let's find out what I am talking about, that dissolved gas content have effect on deep vortex cavitation or not. So our tested range was 4 to 10, I mentioned. So at 9 degree angle of attack, though the vortex strength remains same, but we didn't find any cavity up to 8 ppm, whereas at 10 ppm we find cavity. Let's look at 12 degree angle of attack. So at 12 degree angle of attack, when cavity appears, as the dissolved gas content increases, let's look at 10 ppm, the cavity is approaching towards the tip of the hydrofoil. So it has significant effect in terms of dissolved gas content. Let's look at 15 degree angle of attack. So at 4 ppm, we find the attached tip vortex cavitation. As the dissolved gas content increases, I mean 6, 8 and 10. Let's look at 10. So we find that there are strong partial cavitation as well as we develop the vortex attached cavitation. So this is for another condition, I mean the cavitation number is 1.80. So when the cavitation number was 2.2, we didn't find any cavity up to 8. But here at 1.8, or as the pressure reduction, so we find cavity at 8 ppm, even at 9 degree angle of attack. So as the angle of attack increases, I mean 12 degree and 15 degree. Let's talk about 15 degree. So at 15 degree angle of attack, at 1.8 cavitation number, we find a developed partial cavitation along with attached tip vortex cavitation at 4 ppm. But while at 10 ppm, the vortex is breaking down and the sheet cavity is converted to cloud cavity. So I already mentioned about the intermittent tip vortex cavitation. By intermittent tip vortex cavitation inception, it means that the cavity is not attached with the tip of the hydrofoil. And by intermittent tip vortex cavitation resonance means there are no cavity in the vortex system. So let's look at the right figure. So as the dissolved gas content increases at 4 to 10 ppm, both the inception and resonance cavitation number are increases. But there is a difference between the inception and resonance number. So that effect, maybe we all know that is the hysteresis effect. That there are always a difference between the inception and resonance cavitation number, and this effect is known as hysteresis. So this is the attached tip vortex cavitation. It means that the cavity is continuously attached to the tip of the hydrofoil, and as with the intermittent tip vortex cavitation, the attached tip vortex cavitation with increasing angle of attack as well as with increasing DO content, the cavitation, inception and resonance number are continuously increasing. So that is one of our main findings. Let's look at the intermittent tip vortex cavitation. If we normalize by the highest DO content, I mean 10 ppm, by our lowest one, 4 ppm, we find different sensitivity in both case of inception and resonance. So let's look at the inception figures. So the sensitivity of inception and resonance are different. And if we talk about the attached tip vortex cavitation, it has less DO effect compared to the intermittent tip vortex cavitation system. So this is one of our main novelty. As the time is short, I am describing shortly. So we have also seen that so we have also performed POD analysis, and we can see that there are significant differences in case of partial cavitation for 4 ppm and 10 ppm. So here are my concluding remarks. So the main concluding remarks are, in case of tip vortex cavitation, if we find the intermittent and attached, the sensitivity of DO are significant differently. And also the POD confirms that DO effects have the dominant current fluctuation structure of partial cavitation. Thank you everyone. Thank you for listening with patience. I'd like to accept any question if there are.
다음 세션이 사실 25분 시작인데 너무 제가 시간 많이 들었습니다.